Hello, everybody. So yeah, thanks for having me on today. My name is Zach. I am the CEO of Aztec Labs, and I'm here to talk about privacy and effectively what we've been doing at Aztec, what the thesis is around privacy, and how, in my opinion, we're going to be able to break the bubble of Web3 and of crypto and reach into the real world and actually attract and target mainstream users with mainstream applications. So I've broken this talk down into 3 parts. What is privacy? Privacy is a pretty nebulous word. Why do I think it's important? How do we utilize privacy to reach into the mainstream, expand the design space of what you can do with a blockchain? And then specifically, what is the network that we're building with Aztec, and how can one actually build meaningful privacy-preserving applications today? So, this is my take on how things have been going so far this year in crypto. You know, it's been an interesting year. I believe this is Ivan the Terrible slaying his son, and so 2025 has been a pretty odd year. From the highs of thinking that we're going to have a very open, permissive environment where we're not going to be regulated out of existence, to effectively a large number of meme coins, scams, celebrity tokens, pump and dumps, and I would argue a complete cratering in confidence of cryptocurrency. Certainly, if one goes back to 2015 and thinks about the somewhat cypherpunk ideals that were in the Ethereum white paper, or further back the Bitcoin white paper, the idea of having self-sovereign digital money where you can recreate the financial services ecosystem of the real world, but do it in a permissionless, decentralized manner where you don't have to rely on trusted intermediaries that don't have your interests at heart. We're a long way away from that. And, well, I think there's a reason why. And to articulate this, I want to ask a pretty simple question, one that's been on my mind for many years, which is, where is the fundamental value coming from within crypto? You know, like there's an enormous amount of TVL, there's hundreds of billions of dollars going through crypto every year, but where is it all coming from? And in my opinion, there are only really 2 sources, fundamentally. There's the economic value of consensus on a blockchain network, and then there's dollar-backed stablecoins. And when I mean economic value, I mean literally, if I'm sending a Bitcoin transaction, how much am I willing to pay to get that transaction on chain? How much am I willing to pay to get a record of events that trustlessly attests to this digital transfer? And to articulate what I mean by this, imagine the price of the Ethereum token went to 0, every single token on Ethereum, with the exceptions of USDC and USDT, all of them would also go to 0. And so, really, is the value that they're being derived from fundamentally different than consensus? I would argue no. And in my opinion, this is a problem. It is a giant problem. It's a glaring 3-fire alarm, bright red flashing problem that is being completely ignored by this industry, more or less, which is that the sources of economic value that we generate, capture, utilize within our real-world lives, in the real world, do not propagate on-chain. I'm talking about basic things like real-world assets, land, mortgages, property, bonds, intellectual property, copyrights, even basic certificates, qualifications, attestations of who we are and what we've done. None of this stuff is on-chain. And this isn't why I came into crypto. I came into crypto because I saw the possibility of creating or participating in creating a global distributed ledger of the world's programmable assets, where you have an incredibly fungible marketplace where every single random financial instrument all over the world is no longer this weird illiquid, hard to reason about asset class, but is something which is fully programmable on chain. You can see all the information within it. You can program the rules and conditions around transferring it. And once you have that level of fungibility within assets, those assets start to look a lot like money themselves. Anyway, that, in my opinion, is the original thesis of blockchain, and very unfulfilled. And why is it missing? Privacy. It's missing because we don't have privacy. Because if you want to do real-world transactions on-chain, you need your real-world identity. You need to be able to do compliance, KYC. You need to be able to prove who you are, and you need to be able to be prepared to put that personal information on-chain. And in a transparent world where every transaction can be viewed and dissected and analyzed, this is not practical. But with zero-knowledge cryptography and privacy tech, it is. So this is my answer to what is privacy. It is the great unlock for blockchain and the new frontier of building applications. Previously, we've had Bitcoin, digital gold, then Ethereum came along, and you can now program that. You program your own financial assets, which created stablecoins. The ICO boom, then DeFi and NFTs. But the design space of what you can do with a smart contract has not changed in years, not sufficiently. What's really changed is just the throughput and scale at which these types of transactions can occur. But with zero-knowledge applications, this is now changing. You can do things like use identity attestations to perform uncollateralized loans or loans that are collateralized by real-world assets. You can have decentralized identity apps where you do things like prove using the e-chip in your passport, you prove that you're a citizen of a certain country, and then that's linked to your account. So you can interact with DeFi, where perhaps you need to prove you're not part of a sanctioned country. And things like private votings, it liberates the concept of a DAO. One of the most basic things about a vote is that it's supposed to be private. You're not supposed to be able to see how other people voted, and without that, votes are open to manipulation. DAOs do not have private voting yet. There is a reason why DAOs are ineffective at performing governance, and this is part of it. And so these privacy apps, these ZK apps, they're all enabled through zero-knowledge cryptography, zero-knowledge proofs. So just for folks who are not knee-deep in this technology, just a brief overview, it's basically you have a statement you want to prove, and you can generate a mathematical proof of correctness that can be checked without the fundamental inputs of that proof being known. So, for example, I could prove to you that I know my Apple ID password without revealing what it is. And they're fully private, they don't leak information, and they're succinct, they're very small, which is very important for verifying them within a blockchain. So anyway, I'll skip through some of this, but effectively what privacy enables is things like identity technologies, attestation technologies, being able to prove who you are on-chain, and effectively building trust infrastructure, being able to rapidly gain trust with that you're interacting with an honest, credible counterparty. And giving that ability to trust individuals to smart contracts. And so how do we break this Web3 bubble and reach the mainstream? In my opinion, it's pretty straightforward. There are 3 steps. Step 1, you manage to seamlessly and effectively integrate into Web 2 systems. As in, you can pipe data from Web 2 into Web 3 with the bare minimum of trust assumptions and make it seamless and composable and efficient. For example, being able to prove things about your social media account on chain that you can then use as a form of civil resistance. Or being able to prove knowledge of a Google auth sign-in process or an OAuth sign-in process, so that you can sign into your Web3 account with your Google ID or your Apple account instead of a public-private key pair. And effectively, it boils down to proving data provenance, giving the blockchain some information, telling the blockchain where it came from, and then proving that's correct. Things like ZK email, ZK TLS. Once you can do that, you can also link accounts to identities. Instead of me being a string of instead of my account being OX3 BBB AF9 whatever, no. My account says I am Zachary Williamson, I am 37 years old and a British citizen, except that information is all encrypted. You can't see it. I can see it. You can't see it, but I can reveal that to a smart contract if that smart contract requires it. That's what I mean when I say link accounts to identities. And this allows decentralized applications to perform basic compliance checks, basic like conditions and qualifiers around who can interact within a system that are required for real-world assets. And once you have all of this, then you can start to meaningfully establish digital sovereignty. And by that I mean establish clear legal precedents that a digital asset on a blockchain can be a legal claim to property in the real world. I don't think this is going to be as radical or difficult as it may seem, because there are already a large amount of established precedents about this from the Web 2 world. But this hasn't really been tried yet in Web 3 fully, because there's not much point, because you can't really have real-world assets on-chain in a permissionless environment without privacy. And so how do we unlock all of this? As in, I'm talking about a potential world that can exist. I'm not talking about the world that exists today, because today, all the blockchains pretty much are transparent. And step one, you need a way of being able to work with this privacy technology in an efficient and idiomatic way. You need to be able to go to developers who don't know cryptography. They're not cryptographers. They're not ZK people. They're just software engineers. And you need to give them a language where they can write the program smart contracts that they want to write in the manner that they're used to. And then that automatically, via the compiler, via the backend, it all gets converted into this zero-knowledge proof technology. That's what we've been building at Aztec with Noir, Rust-like programming language, one of the fastest growing ecosystems within Web3, and it enables this. Once you have your programming language, you need an execution environment for your smart contracts. And this really is key. You need this concept of private composability, where you can have smart contracts that call other smart contracts that call other smart contracts, et cetera, but they're all private. This means that your blockchain needs an understanding of private state. It means that you need to be able to send a transaction on that blockchain, and the message sender is unknown. This basically requires a radical re-architecture of what a blockchain even is, and that's what we've been building with Aztec, which is a layer 2 on top of Ethereum. And finally, you need some extraordinarily state-of-the-art cryptography to make this all practical and possible, so that you can actually generate these advanced zero-knowledge proofs on a laptop, on a phone, because if you're performing private transactions, that private information really, you want that to stay with the user, not shared to a third party by getting a third party to prove it. So you want your proofs to run locally. That's very challenging. That's what we've been doing over the last 7 years. With our cryptography and our first-party research. And so I was talking about a future world that exists, but that future world is starting to become real, as in privacy technology is being used today to build the future of Web3. It's being used for things like trustless proofs of email. With a ZK email, I can prove that I've received an email from a certain domain signer, and I can prove statements within that email. This was used, I believe, in a hackathon by an Indian food delivery startup, where if you got an unsubscribe email from their competitors, they would give you some credits, which I think is a very fun use of this technology. You have anonymous social media broadcast posting with Anoncast. If you prove that you possess Anoncast tokens, you can post on the Anoncast account and hide who you are. Then you have some more like financial work. For example, trustless on- and offboarding into and out of crypto, using things like Europe's open banking API or using ZK email, which Pay and ZK-PGP both do. Bank-grade private security tokens are being built today with Noir. And effectively, what we're seeing is the start of the genuine debank that people were idolizing about 5, 6, 7 years ago. The idea that you could actually create bank-grade financial services, not just for synthetic tokens and assets on Ethereum or Bitcoin or Solana, but actual real assets that exist in people's real bank accounts. And we're starting to see the seeds of that today with Noir. Done this a little bit out of sequence. So Noir is, this is a very toy example of some Noir code, but basically it looks and talks and quacks like Rust, and it's fully open source, extraordinarily flexible. You can write it, you can write your programs in a very high-level style, but also if you really want to and need to, you can hyper-optimize your code so that the ZK circuits that you create are completely optimal. And to give an example of what's going on in the Noir universe, we're right now running Noirhack. It's an online 4-week hackathon. We've had over 500 signups. We were aiming for 100. We have 500. So this is going to be going on over the next 4 weeks. Hopefully we're going to get a lot of extremely valuable, innovative projects out in our demo day in 4 weeks' time. So pay attention to our Twitter, and you'll see all about it. Now I want to talk a little bit about the Aztec network, because Noir is basically step one of that 3-step piercing the Web3 bubble thing. But a ZK language by itself is not, it's useful, but it's not transformative, because let's say I have a little privacy-preserving application that I build with Noir. I can verify those Noir proofs on networks like Ethereum or Solana, which means I can have some level of privacy on these networks. But if I build an application with that type of technology stack, then I have very custom software on the downstream of that application required to generate those zero-knowledge proofs and to consume and understand the information produced from those proofs, which breaks composability. Because now if, let's say, one of those apps gets deployed and I am a developer and I want to use that app within my own application, then now I need to incorporate all of the ZK technology that upstream application used in their app, all of the JavaScript side proving elements, all of that extra infrastructure and code. I need to inherit it. And you can see how this doesn't scale now, because if you have 15 different ZK applications that all need to interface with one another, and then I want to build a ZK app on top of that, which incorporates all of those 15 applications, then I now have an unwieldy mess of complexity to handle all of the proving and information passing between these systems, because it's all relatively custom. What you really need is an execution environment. Aztec is to Noir what Node.js is to JavaScript. It is a distributed transaction network that has a private state as a first-class primitive within it, where you can write your smart contracts in Noir and deploy them, and you can seamlessly call other smart contracts written in Noir, just like you can on Ethereum, just by using RPC node server calls. And you don't have any integration complexity. So with a private smart contract, you have the identity of the transaction sender is fully anonymous. Your state can be completely private, encrypted. The functions that you're executing within your smart contracts can be completely hidden, as in by observing transactions on the blockchain, an observer cannot see what functions you're calling, and they can't see what contracts you're calling either. So all you know is that somebody called a smart contract, or more than one smart contract on this network, and some state got changed, but what state, nobody knows. But you can still prove, mathematically prove that if you're sending that transaction, you're following the rules of that blockchain network, that the smart contracts you're calling, you've faithfully executed them, you're not cheating, you're not lying, you're not deceiving. And this is all backed up by zero-knowledge proofs. It is really quite genuinely radical. And our contract model for Aztec, if you want to build with it, is effectively, an Aztec smart contract differs from a contract like Ethereum, on Ethereum or Solana, because it has this concept of private and public functions. A public function is very much like a function within a Solidity smart contract, where you have public state, you modify it, job done. Private functions are a little different, where you have private state that you can modify. That private state is owned by users. It's owned by them because their users have secrets that are required to decrypt this information. You can emit private events. So you can emit events on your blockchain that are completely encrypted and ciphered apart from for the intended recipient. And private functions can call public functions. So you have this kind of public-private composability. And this is very important because with private state, one of the limitations is it's owned by somebody because it's encrypted. So if I want to write something like an AMM, a decentralized exchange, well, that's challenging because I will need things like, I will need to know what the total liquidity supply is for an asset class. And that's going to change for every transaction. So who owns that state variable? Well, nobody does. The way that, one of the models that we're proposing with Aztec is this concept of privacy for the user and transparency for the protocol that those users are interacting with. For example, in Aztec, you could create a completely public DeFi exchange, a completely public AMM. So the prices are open, the trades are all known. However, the identities of the transaction senders and the identities of the token holders is not known. The idea is that the token contracts are private, but the exchange is public. So you get strong privacy guarantees. And then also that public decentralized exchange can also make private queries about a user's identity if they need to perform compliance checks as well. You can do things like transaction limits. So let's say maybe you need to cap people at transferring less than $10,000 of an asset class because it's a real-world asset that's regulated. You can do that with this kind of model. And this is the public-private composability I've been talking about. So you probably can't see it that well, but this is basically some code taken directly from our Aztec libraries for performing a public token transfer and a private token transfer. So go to docs.aztec.network if you want to read more into how this all works. So we've been building Aztec for many years now. I've been working on this arguably for 8 years. We've been doing privacy solidly for 7 of those 8 years. It's taken a long time because the technology required to implement a private programmable blockchain has not existed until basically today, this year. Previously, like for example, we've had to do a lot of first-party research to make this kind of technology possible. Going back to 2019 with the publishing of the Plonk ZK snark, which was it was the first practical ZK snark that didn't require trusted setups for every single program that you wrote, which was the fundamental requirement to have a programmable private network. The idea is you write a smart contract, you don't perform a trusted setup ceremony, you just write your smart contract, you deploy it. That was why we developed Plonk, is to enable that. But now the actual technology we use is an iteration of Plonk, which is like 250 times faster, because we've had to constantly research, innovate, build products with the state of the art, and then move on. And obviously, this is not this is far from a solo effort. It's taken the combined efforts of many thousands of researchers and engineers and builders across the entire Web3 ecosystem to make this all possible. But long story short, we've been doing this for 7 years. But our public testnet is now imminent. I wish I could say more, but keep your eyes peeled on the news. For the foreseeable future, something will happen. It's fully decentralized from day one. Another reason why it's taken us so long. This is a privacy network. We cannot have centralized nodes of control that can censor transactions or that would have or that can spy or see on transactions. So it needs to be fully decentralized, fully permissionless from day one, and that includes our testnet. And it's effectively an end-to-end encrypted blockchain where you can genuinely create these fully private transactions and fully private applications where you can hide critical information about a user so that they can enjoy feature-rich applications without having to sacrifice critical data privacy. So yeah, how to get involved? Go to docs.aztec.network or scan this QR code. This is a basically getting started guide and join the hundreds of developers already building with this. Ultimately, the reason why we're building Aztec, the reason why we set about on this path is because we wanted to expand the design space of what you can do with a smart contract, to move beyond the synthetic kind of casino abstractions that we have at the moment, where all the tokens are somewhat made up and just derived from economic consensus. We wanted to enable developers to build real-world systems, real-world products, and that's what's happening today. And in my opinion, obviously I'm biased, but I think this is the most exciting place to be. So, final slide is basically, again, a bit too small to see. This is our roadmap to mainnet. Building a completely decentralized, programmable peer-to-peer private transaction network is not easy, but we're actually more or less on target. So we've had a lot of verticals we have to handle, from the proving system cryptography to the actual node engineering to decentralization. But basically, you can follow this along on our roadmap. Go to our website, check the roadmap. We update it pretty much every single week. And stay tuned, because mainnet is not far away now. Anyway, that's me. Thank you very much.